Hi everyone, so welcome to another episode of That Coder channel. So today let's talk about system design. Alright, so if you think system design is hard to learn, I'll make it simple for you guys. So let's start with the basic services we use to build most of the backend infrastructures. So this is the basic architecture of most of the basic backend systems. So usually what your front end will do is the front end will invoke a REST API call to your backend service. Your backend service will get the data from the in-memory cache, right? So if still it didn't get the data from in-memory cache, it will go to the database, the primary database itself, and return back to the front end. Alright, so to update the in-memory cache and your multiple databases, you need a service in between. It will invalidate your cache, and for running multiple asynchronous jobs, you will have a multiple set of queues or consumer programs running parallelly. Okay, so let's talk about each block. So first let's talk about vertical versus horizontal scaling. So vertical scaling means you will add more memory or hardware to your existing machine. So horizontal scaling means you will create multiple machines for scaling. All right. So if you work in MongoDB or any NoSQL databases, you may know this about creating multiple replicas. So horizontal versus vertical is also one of the building blocks of SQL versus NoSQL. So one is records in a table, and one is document based key value store database, right? So SQL versus NoSQL. So most of the SQL databases are vertical scaling databases, and most of the NoSQL databases are horizontally scaling databases. So these are the examples you can. So these are the databases you can use as SQL databases and NoSQL databases. Alright, so in NoSQL you may also use big data systems like Hadoop, Cassandra, etc. Right? So when it comes to caching, so the first way of caching is you can cache your static assets and most of the get API data inside your CDN level itself. So you can use Cloudflare, CloudFront, Akamai, Google CDN, etc. for as a CDN network, or in-memory cache in your own infrastructure itself, like a Redis or memory memcached engine. So most of the caching engines are NoSQL principled cache engines. So that means it also store key value pair data. Okay, so why we need a separate search engine? So making database choices are always tough. So I know when we build systems, so sometimes you start with a SQL database, but at a point when your application scales, you definitely need a NoSQL database to scale horizontally. So to store your previous data or millions of records. And also after maybe 1 million records or documents, even in NoSQL databases, you may encounter like your search will start to slow, full text search or facets. So at this point what you can do is, so you can come up with a search engine like Elastic, Solar, Lucene, or Algolia. So these are search optimized databases. So this will yield you guys more search related query performance. Okay, so for running asynchronous task like When someone requests for data, for example, when a user register to your system, then you need to send a welcome email, right? So this is not time dependent. So at that point, you can pass this data to a asynchronous system. So at that point, you can use something like Kafka or RabbitMQ as a queue engine. So this Kinesis, SNS, and SQS are managed services offered by AWS, and task queues and other queues are there in Google Cloud and Azure. So this step function and Airflow is one of my favorite right now. So what this will do is, so this will create a flow, right? If step 1 happen, do the step 2. For example, when you get some data, first you process some building block, right? Like enriching your data. So process, maybe you removed characters from there, like a special characters from the data. In the second step, you will do another one step. So only if the step 1 happen, jump to the step 2. So you can build these kind of uh, steps or workflows inside step using step functions and Airflow. All right. So let's revisit the architecture. So when the front end requests some data or service, so it will first hit inside the backend service. Um if the data is there in in-memory cache, get the data from in-memory cache, else get the data from the primary database. Okay. So think about like you are building an e-commerce system, so where you will have a full text search on the top and facets on the side, plus you have full text searches as well, right? So aggregations pipeline, etc. So at that point you will introduce a search optimized database here, like Elasticsearch, Algolia, Lucene or something, and you will offload all the search related to through here to here. Okay. So for keeping the same copy of the data between these data store, another one backend service will run. So usually what most of the application will use is we get the connectors, like Kafka connectors, which are change stream events of this database changes. So if a insert or update or delete event happen inside this database, it will trigger the connector, like it will pass the data to the connector in between here, and it will trigger the backend service. So it will update then the in-memory caches or the search databases. Okay. So if you want to have multiple asynchronous jobs running in parallel, then you will offload those works to a queue in middle. Okay. So here this will act as a publisher, which is which is the node which send the data to the queue, and these are the consumer programs. So for example, you are instructing to send a mail to the outside world, so it will pass the mail ID and the content to this queue, and there will be a corresponding microservice program running. It will consume the message data, and it will send the data to the outside world. Okay. So I think you guys got the idea of the backend system architecture. So these are the next episode I'm planning. So to get this episode, please subscribe to the channel and click on the bell icon to get more and more updates. So thank you guys for watching. Bye bye.